Now that we've explored our ionic bonding, let's take a look at covalent bonding and what happens with electronegativity and polarity. All right, so in covalent bonding, what's happening with the electrons? They are what? They are shared. Okay, so in our covalent bonding, the electrons are shared. So we get an overlap of atomic orbitals. We're going to cover a lot more about this overlap when we talk about valence bond theory in another chapter. And so because each atom involved in the bond considers all the electrons in the bond belonging to them, we get a filled valence shell. Okay, and so we can depict our bonds. So there's a single bond between two hydrogens. There's a double bond between two oxygens. There's a triple bond between these two nitrogens. And what am I doing? There we go, that's better. Okay, and so we show our bonds with those lines, and we show our lone pairs with our dots. Now, when we look at our electronegativity, this is how we determine polarity, right? So every element has its own electronegativity value. And so when I have two atoms that are covalently bonded together that each have a different electronegativity value, I get a polar bond, where the more electronegative element attracts the electrons more strongly. So we get a positive and a negative end. And so these are partial positives. So we get a partial positive and a partial negative. All right. And so the more All right, so that more electronegative element attracts the electrons stronger. Okay, so let's take a look at something like hydrogen fluoride. All right, so hydrogen fluoride is polar. Fluorine is more electronegative than hydrogen. So when I look at these, I can depict this with two ways. Okay, this red arrow here, this is what we call a polar arrow. Sometimes you'll also see the bond itself done like that. Okay. And then here with these delta symbols, these are showing the partial charges. Okay, and so because the bond is polar, if I put them in an electric field and I turn that electric field on, they'll align with the electric field. The partial positive end will be attracted to the negative part of the field. The partial negative end will be attracted to the positive end. Okay. So when I look at polarity, this is where we can go between our different bond types. A nonpolar bond or a pure covalent bond, things are going to be shared equally. So if I have something like hydrogen bonded to hydrogen, same thing. My change in electronegativity will equal 0 because they should each have the same electronegativity value because they're the same thing. And so this is where I get my pure okay, which is non-polar, okay? And then if I get enough of an electronegativity difference, that's when I have a polar covalent bond. So something like hydrogen fluoride. Again, obviously that has a difference in electronegativity. So my delta, my change in electronegativity will not be 0, all right? And so we get a polar covalent bond. All right, and then we get an ionic bond when the electronegativity difference is so strong that we get a full transfer of electrons. And this is why our ionic bonds are between the metal and the non-metal, because what's happening is the metals are usually much, much lower in electronegativity compared to non-metals. And so the non-metals have such a high electronegativity, they attract that electron so strongly that they can pull it completely off the metal, and we get the ionic bond, okay? And so when I look here, if I look at sodium chloride, there's my ionic bond, hydrochloric acid or hydrogen chloride if it's in the gaseous state, there's my polar covalent bond, and then a chlorine is going to be nonpolar. And so again, I can depict with my polar arrow. Or with my partial charges. Okay. So electronegativity. It's the ability of an atom in a bond to attract electrons toward itself, i.e. it's the electron greed. The more electronegative something is, the more greedy it is for electrons. So one thing to note, okay, electronegativity increases up and to the right as do the ionization energy and the electron affinity. Okay. All right, and so here we have some electronegativity values. The most electronegative element on the periodic table is fluorine. It is the most electron greedy out of any of the elements out there, followed very closely by oxygen. Oxygen is the second most electronegative element. All right, so these guys are super electronegative. All right, fluorine again, the most electronegative element. So hopefully this was all a review. None of this should have been anything new from what you learned about electronegativity and polarity back in your prep chem class. So hopefully that was just a review for you.